Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a gem dicarboxylic acid, malonic acid type, is heated, it undergoes decarboxylation, loss of CO2 to give a monocarboxylic acid. Then, further heating causes loss of water. Moving on to the next step. The structure shown is cyclohexane, 1,1 dicarboxylic acid, a gem dicarboxylic acid where both CH groups are on the same carbon of the cyclohexane ring. Moving on to the next step. Gem dicarboxylic acids, malonic acid derivatives, readily undergo decarboxylation upon heating to lose 1CO2, yielding cyclohexane 1-carboxylic acid, cyclohexane carboxylic acid. This is a monocarboxylic acid. And for the final step, a simple monocarboxylic acid upon heating does not form an anhydride intermolecularly under normal conditions without a second carboxylic acid group nearby. However, since the product after decarboxylation is simply cyclohexane carboxylic acid, a monobasic acid, and the question asks for the final product after both steps, the product is the monobasic acid, cyclohexane carboxylic acid. The second step, H2O, here refers to the elimination within the decarboxylation mechanism or describes the overall transformation. Why not anhydride options A, B, or C? An anhydride requires two carboxylic acid groups to condense. After decarboxylation, only one CH remains on the cyclohexane. A cyclic anhydride from a single CH is not possible. Furthermore, cis trans anhydrides would require a dicarboxylic acid with geometric isomerism, like phthalic acid, which is not the case here. So options A, B, and C are eliminated. The product after decarboxylation, CO2, and loss of water, H2O, likely referring to the tautomeric mechanistic steps, is a monobasic acid, i.e., cyclohexane carboxylic acid. Therefore, the correct answer is A. Therefore, the correct answer is option A.